This next lesson is all about word problems, our favorite word problems. So these are multi-step word problems, so we're going to look at how to break these word problems down into simpler problems for us to solve. Let's take a look at this first word problem. It says, at SeaWorld, one section of the Sea Lion show has 9 rows with 18 seats in each row. In the front of each of the first 3 rows, 8 seats are in the splash zone. How many seats are not in the splash zone? So that's what we're looking for. And I want you to make sure you have a sheet of paper out with you. And what's important right here is we're looking for how many are not in the splash zone. Now this gives us a lot of information. So what we're going to be doing with these types of problems is drawing either a diagram or a table to help us figure out how to solve our problem. So we're going to go ahead and we're going to start by drawing a rectangle so we can see what we're dealing with here. Now we need to go ahead and we need to label our rectangle. Well, we have 9 rows and there are 18 seats in each row. So that's what I'm going to do. I'm going to label my rectangle 9. And that 9 represents my rows, and then 18, and that 18 represents my seats. Now, my problem also mentions that in the first 3 rows, 8 seats are in the splash zone. So I'm going to draw a second rectangle inside my first rectangle, and it's going to represent those 3 rows and 8 seats. So I need to label that rectangle 3 rows and 8 seats in each of those rows. And those are in the splash zone. Now what I'm looking for is how many are not in the splash zone. So what I really want to try and find is how many seats are in this green area. How many are not in that purple splash zone area. In order for me to do that, I'm going to have to find, well, how many seats are in that total section? How many seats are 9 rows of 18 seats, or 9 times 18? Then I'm going to need to find, well, how many seats are in this splash zone area of 3 rows and 8 seats in each row. And then since I'm looking for how many are not in the splash zone, I'm going to have to subtract my whole and my part to find my other part. So I first have to start with some multiplication, and I need to start to find what is 9 times 18. Now I can do that using any of the methods we've learned so far, so I'm going to choose to use partial products to find what 9 times 18 is. If you want to choose another method, go for it. You can use the area model, or you can use expanded form to solve 9 times 18. When I use the partial products method, I get 90 for 10 times 9 and 72 for 8 times 9. And when I add those together, I get 162. And this is my total number of seats. So there are 162 total seats in that section of the stadium. Now the next problem that I need to solve is to figure out, well, what's my splash zone? What's this purple area here? So to solve that problem, that one's going to be pretty simple. My splash zone is going to be equal to 8 times 3. And 8 times 3, we don't have to do any fancy multiplication. That's equal to 24. And this is going to be our splash zone. Now, if we want to figure out what this green area is, what everything except for our splash zone is, we're going to need to do some subtraction. So we're going to take our whole, or our total of 162, and we need to take away or subtract those 24 splash zone seats to figure out how many seats are not in the splash zone, because that's what my question is asking me. How many seats are not in the splash zone? So I'm going to go ahead and I'm going to subtract. I need to borrow and regroup in order to subtract. And then I get my final answer. There are 138 seats that are not in the splash zone. And that would be the final answer to my problem, 138 seats not in the splash zone. So again, notice the steps that I took to solve this problem. I drew a diagram to help me out. I saw that I needed to find my total number of seats. I needed to find the part that they were talking about for the splash zone, and then I needed to subtract to find what was not in the splash zone. I want you to solve this problem. Emma is going to a play. At the play, there are 8 rows with 21 seats in each row. In each of the front 2 rows, there are 15 seats reserved. How many seats were not reserved? Were not reserved is what we're looking for. So go ahead and draw your diagram. figure out the total number of seats, figure out the seats that are reserved, and then figure out what you have to do in order to figure out how many seats are not reserved. So here's my diagram. I have my total number of seats are in black, so that's 8 rows with 21 seats in each row. And then inside that bigger piece is a second piece that shows me that 2 rows of 15 seats are reserved, and I'm looking for not reserved, so I'm looking for that purple area. In order for me to solve that, the first thing I'm going to do is multiply 8 times 21 to find the total number of seats. Then I'm going to multiply 8 times 15 to find the seats that are reserved, and then I need to subtract to figure out how many are not reserved. So I'm going to go ahead and use the expanded form method. 8 times 20 gives me 160, and 8 times 1 gives me 8. So my total number of seats is going to be 168, and this is my total seats. Now I need to multiply to figure out what my reserved seats are. So I need to multiply 2 times 15. I don't need to set up an area model or anything for this one. 2 times 15, I already know that's equal to 30. I'm just doubling 15. I could add 15 plus 15 to find that out, or I could use one of the methods that I've learned. Now my final step to figure out how many are not reserved is going to be to subtract. So I'm going to go ahead and I'm going to subtract 168 minus 30, and that gives me my seats that are not reserved, which is 138. So that's my final answer. 138 seats are not reserved. With these types of problems, when in doubt, draw a model to help you. Here's another problem for you that I want you to solve on your sheets of paper. The concert hall has a section A and a section B. In section A, there are 8 rows of 25 seats in each row. In section B, there are 6 rows with 16 seats in each row. How many seats are there in section A and B? So in these problems, we are looking for how many were not in those sections. This one, I want section A and section B. So go ahead and draw yourself a model and solve this problem. So to solve for section A, I'm going to be multiplying 8 times 25, and so I'm going to draw my model, and then I'm going to use it as my area model to solve. And for section B, I need 6 times 16, so again, I'm going to use my area model. And so I'm going to solve for each of my pieces. And I'm going to solve for section A, I'm going to solve for section B, and I need to find what their totals are. And because I'm looking for and here, section A and section B, I'm going to end up adding my 2 sections together. So my total number of seats for section A is 200 seats, and my total number of seats for section B would be 96 seats. So all I have to do is add my 2 seats together, and so I get 296 total seats in section A and B. So my total answer is 296 seats. So these past few problems, those models are really helpful to draw so we can figure out how we're solving them. This next problem and the next 2 problems that we're going to look at, they're not going to be the types of models that we just drew. We're going to have to do some lists and solve for each person so we can solve the problem. This first problem we're going to do together. It says Lauren, Paul, and Mary all have dogs. Lauren's dog weighs 10 more pounds than Paul's dog. Mary's dog weighs 2 pounds more than twice the weight of Paul's dog. Paul's dog weighs 12 pounds. Find the weight of each person's dog. So what I'm going to do is I'm going to list Lauren, Paul, and Mary, and I'm going to start writing equations for each person so I can figure out how much each person's dog weighed. So here I have their first letters of their names in order to signify each person. Now, Lauren's dog weighs 10 more pounds than Paul's dog. When I see 10 more pounds, that shows me I'm going to be adding. Signifies addition. So 10 more pounds than Paul's dog. So Lauren is equal to 10 plus P, or Paul's dog. Mary's dog weighs 2 pounds more. 2 pounds more, so that's addition. 2 pounds more than twice the weight of Paul's dog. Where I see twice the weight, that's going to signify 2 times Paul's dog. So I'm going to go ahead and I'm going to write an equation for Mary. Mary's dog weighs 2 pounds more than twice what Paul's dog weighs. And I'm going to put this part in parentheses because that's what I need to solve first. Then our problem says Paul's dog weighs 12 pounds. So Paul is equal to 12 pounds. So now that I have all these equations, and now that I know what Paul's dog weighs, I can go ahead and replace my P, or my variable, in each of these problems with what I know for Paul's dog. So I'm going to replace my P with my 12. Now these problems are pretty easy for me to solve. Lauren's dog, 10 plus 12 is equal to 22 pounds. And then for Mary's dog, the first thing that I'm going to do is I'm going to solve 2 times 12, and that's going to give me 24. And then I need to add 2 more. So Mary's dog is going to weigh 26 pounds. So I have Lauren's dog weighs 22 pounds, Paul's dog weighs 12 pounds, and Mary's dog weighs 26 pounds. And I used a list method and wrote an equation for each person, which then helped me solve for each person. After I found what Paul's dog weighed, I could go and replace all of those P's with that amount. I want you to give this next problem a shot. It says Luke, Max, and Jake all played football together. Luke scored 3 times fewer points than Max. Jake scored 3 more than 2 times as many points as Luke. Max scored 24 points. How many points did they each score? Go ahead and start with Luke, Max, and Jake. Write an equation for each person and then solve for each person's amount. Alright, so here are the equations that I have set up. Luke scored 3 times fewer points than Max. So 3 times Luke is going to give me what Max scored. Max scored 24 points, and Jake scored 3 more than, so 3 plus, 2 times what Luke scored. So the only person who I know right now, I know how many points they scored, is Max. I'm going to go back into my equations that I set up, and whenever I see an M, I'm going to replace that with Max's score. So I saw an M in Luke's equation, so I replaced that with 24. Now I can solve for Luke. I need to think 3 times what gives me 24? Well, 3 times 8. So Luke scored 8 points. Max scored 24 points. Now that I know what Luke scored, I can replace my L down in Jake with my 8. And now I can solve for Jake. 2 times 8 gives me 16, plus 3 more gives me 21. So Jake scored 21 points, Max scored 24 points, and Luke scored 8 points. These problems are super, super tricky, guys. We need to be able to take what the words say and create equations out of them and then solve for our missing amounts. Okay, I have one more problem for you to solve. This one is actually super simple. So Mr. Lassiter has 49 students in his classes. He gave each student 3 pencils. How many pencils did Mr. Lassiter give out? Solve this problem now. This problem is just a simple multiplication problem of 3 times 49. Now, using some of the strategies that I've talked about earlier, I could make this problem even simpler for myself. I don't have to do my area model to solve this problem. I could set it up as 3 times 50 minus 1. And then I would expand, so 3 times 50 minus 3 times 1. 3 times 50 is equal to 150. Minus 3 gives me my total of 147 pencils. You could solve this problem using the area model or expanded form or partial products, and you would also get 147 pencils as how many pencils Mr. Lassiter gave out. Okay, that's our lesson for today. See you tomorrow when we focus on multiplying with regrouping.